Assalamu alaikum everyone, my name is Faizan Sheikh and today I'm going to be teaching lesson 6.1 and 6.2 for advanced functions. So what the first lesson is, 6.1 is an introduction into the unit of radians. So typically since grade 6, grade 7, we've been using degrees to calculate angles. So you may have recognized some of these degrees, like 30 degrees as you can see here, 60 degrees, and you may even know them as the primary trig ratios. So far, we've only used degrees to measure angles. Now, what I'm introducing today is radians. So radians are another way to measure degrees. They're another measure of degrees, another way to measure angles, right? So as you can see on this circle, there's many different ways that radians are expressed, and they're expressed in terms of pi. So for example, we could go through this circle and see just how the conversion works from degrees to radians and vice versa. And the benchmark I like to use is that 180 degrees is pi radians. Alright, so that's the benchmark I like to use. And then using that benchmark, we can see that 360 degrees is 2 pi because 180 times 2 is 360. So 1 pi is half a circle, and then 2 pi is 2 full circles. So we can just go through this one by one to get it through your head that the conversions between degrees to radians is 180 degrees to pi radians. Alright, so starting off from 0, of course that would be 0 pi. Then you have 30 degrees. This would be 1 pi over 6 because, as we know, 180 degrees divided by 6 equals 30. So you have 1 pi over 6 or just pi over 6. Next you have 60 degrees, which if you want to continue the denominator of 6 pattern, you can keep going and it would be 2 over 6 because 180 divided by 3 equals 60, which is how we get pi over 3. And then we have 90 degrees. So this is 1/4 of the way into a full circle. And since a full circle is 2 pi, then this would be pi over 2. Because this at 45 degrees, which we'll cover in the next few slides, would be pi over 4. Because 4 times 45 is 180. So at 90 degrees, which is 2 45s, it would be pi over 2 or 3 pi over 6. So next let's go to 120 degrees. So right here, this is, as you can see, this is going by 30 degrees. It goes from 0 to 30, 30 to 60, 60 to 90. And as you could probably tell, each is skipping by 1 over 6 pi. So then 120 degrees would be 4 over 6 pi, which is also 2 pi over 3. And then you go 30 more degrees, which is also 1/6 more degrees, more radians in terms of pi. So that would be 5 pi over 6. And then you get to the benchmark that I like to use and that I find the most simple, which is pi or 6 over 6. Then you have 210 degrees, 30 more than 80, 1/6 more than 80, which is 7 pi over 6. Next you have 240 degrees, which is 8 pi over 6, or when you simplify that, it's 4 pi over 3. Next, 3/4 into it is simplified 3 pi over 2. This is because that over here it would be 2 over 2, because if you're going by quarters, this would be 1 over 2, this would be 2 over 2, or 1 whole, this would be 3 over 2, and this of course would be 4 over 2 because it's 2 pi. Next you have 300 degrees, which will turn into 5 pi over 6, 330 degrees, which will turn into 11 pi over 6, and finally 360 degrees, which if we're going by the 1 over 6 addition, it would be 12 pi over 6, which is also just 2 pi. So now you get the gist of how to convert radians to degrees and vice versa, using this benchmark of 180 degrees is equal to pi. So next, what exactly is a radian and how does it work? So in this illustration below, theta is an angle described in a radian measure. So this equation shows exactly what theta is equal to when we're using radians. So theta is a, which is the arc, over the radius, and that's how you find the degrees in radians. So next, examples of radians in a circle. And for this, we're just going to go by one without the conversion into radians. So in your head, I want you to, because obviously we can't speak to each other in this lesson, I want you to think, what will 0 degrees be in this? Or 360 degrees. So both of them in one, since they're at the same point within a circle. So just for a second, think about what it would be. So if you said that, of course, 0 would be 0 pi, and then 360 would be 2 pi, you're correct. And now for 60. So remember that 60 is 180 divided by 3. 180 is pi. So using that, what would this be? If you said 1 pi over 3, that's correct. Alright, next you have 120 degrees, which is 180 divided by 3 times 2, which if you said 2 pi over 3, you would be correct. And now the benchmark I always say, it's also to the right over here. 180 degrees is pi. Then you have 240 degrees, which is another third pi added to pi. So that would be 4 pi over 3. And then finally, you have 300 degrees, which is another third pi. So you get the gist of it now. It would be 5 pi over 3. Next, moving on to lesson 6.2, because pretty much that was it for 6.1. All it was converting degrees to radians and vice versa. And all you really have to do is use that 180 degrees as a benchmark. So 180 degrees equals pi, and you could convert any amount of degrees to any amount of radians. Okay, so now moving on to lesson 6.2. How can we apply these measures of radians onto a Cartesian plane? So starting off, we're going to go through the primary trig ratios that we learned last year. So starting off, you got sine theta. So when we're just going to go through it. So sine 30, which is also pi over 6, as we know, because 180 divided by 6 equals 30. So pi over 6, sine would be 1 over 2, cosine would be root 3 over 2, tan would be root 3 over 3, cosecant would be 2, secant would be 2 root 3 over 3, and cotangent would be root 3. And then you have 45 degrees, and as we know, 180 divided by 4, as you can see here, is 45. So that's why it's pi over 4. And then when you put this into sine, you get root 2 over 2. Cosine, you get also root 2 over 2 because it's 45. Tan, you get 1. And we could use these triangles as a base of measure. So for this, these 30 angles, you can see that 30 is pi over 6, which is also over here. So what is sine? Sine is, it goes soka toa. So sine is opposite over hypotenuse. So as we can see here, the opposite of this angle is 1 over the hypotenuse, which is 2, which is exactly why sine theta is 1 over 2. And you could use these triangles and see over here it's in degrees, but over here it's in terms of radians. So the same rules apply. You just have to convert the degrees to radians and everything is the same. So you could use 45 for this triangle. So 45, I think we were on tan. Tan would be 1, cosecant would be root 2, secant would also be root 2, and cotangent would be 1. And then you have for 60 degrees, or pi over 3, sine would be root 3 over 2, cosine would be 1 over 2, tangent would be root 3, cosecant would be 2 root 3 over 3, secant would be 2, and cotangent would be root 3 over 3. And we could see this, as I said, using the primary trigonometry ratio triangles. So over here, this pi over 4, this is the 45 angles. This pi over 2 and the pi over 2 here, this is 90 degrees. So this is not in the primary trig ratios, but this is also useful. So next we have examples of sine, cosine, and tangent in radians. So we're going to try to